So another Patreon exclusive video, this time about the GridSeq from JW, which might look simple at first, but it's very deep and can yield unique results. And as always, we will start with the basic functionality. So here we have a grid of 16 steps, right, and a few direction inputs that we can use to drive the sequencer. So let's do this. I will connect the gate output to, in this case, the FM operator, also the output, which will be pitch. And now I can click the arrows to move the sequence. So for example, I can move forward, right, from left to right, or I can use a clock to do this for me. I have a clock multiplication of 4. Right, and now we can change the value of each step. Right, we can turn steps on and off. Let's leave them on for now, but we can also add probability per step with these little knobs here. Right, so here, for example, 0.7, here 50%. Right, so already from just 4 steps we have some variation. Now I can click the arrow down, move to the next row, and again, make some changes. And do this, let's do this for all the 4 rows. Right, something like this. Right, and now I can use a slower clock, right, to trigger the down arrow, and then we can get a 16-step sequence. So here again I have a multiplied by 4 clock, so I need a divided by 4 from this, which will just be the normal clock. Right, for each 4 clock triggers here we get 1, which means that we get 4 steps and then 4 steps and so on and so forth. Right, now we can change here the root note. So for example, we can go to G. This will just transpose the sequence. Right, we can change the octave. We can change the scale. For now it's on minor. I can go, for example, to major. Change the range. So we have 2 volts, 1 volt, 0 if you want. Or increase the range. Right, so also just with this basic functionality we can create very interesting sequences, but let's dig deeper into these pitch and range controls. Okay, so here I have a sequence running, sequencing the dark energy from the geodesics. Right, again I'm using 2 clocks, one to drive the forward trigger input and another one to drive the downward input. Right, so again we get 16 steps. And the first thing we can do is sequence the root note transposition to get variation in pitch. Right, for this I like using the ADDR sequencer. Right, I have it set to 4 steps. Step 1 will transpose by 0, so it will not transpose. Step 3 the same, so 1 and 3 will not transpose, but step 2 will transpose by 5 volts, which would be the note F, and step 4 will transpose by 7 volts, which should be the note G. Right, so I will connect this to the root note CV input on the sequencer, and I will drive this with a divided by 16 clock, so the sequence will play twice and then will transpose. Let's reset everything, and let's listen to this. Right? So you have movement in transposition. Very nice. I have here another sequence. This is sequencing the FM operator. You see I have a few notes off here, but again I'm using 2 clocks. Right, so one will move forward, the other one will move downward. It will sound like this. Let me solo this maybe for a second. Right, now first of all what we will do, I will use the ADDR sequencer to transpose also this sequence, so they will be transposed together at the same time. And now what we can do is, for example, randomly increase the range right, and add variation to the sequence. So in this case, I will use the sequencer from count modular, right? It can run randomly. See direction, it has forward, pendulum, reverse, and then random. So it will jump from one step to another randomly, and I have only 2 steps set. Right, so there is not so much probability to land on those steps, and this I will use to control the range randomly. Right, so only on those 2 steps the range will change, right, and this happens more or less randomly. Let's bring back the dark energy voice. Right, now since I'm using a dedicated sequencer for this, I also have access to the trigger or the gate output, right, which we can use to add even more variation. For example, we can send the FM operator only when it's being transposed, let's say with the range, only when the range is changing, only then we can send it to a delay. So I will send a copy of the FM operator to a VCA, right? I have the VCA controlled by an envelope, and this is going to a delay module. So if I use the triggers from the sequencer to control or to open the envelope, only when it's transposed, just like now, only on these 2 steps, which are again happen randomly, only then it will go to the delay. There are 3 buttons in the lower right section of the module of the sequencer that we can use to randomize things and either add variation or experiment and find interesting results. So here I have Platts as my voice. I will start the clock. Right, and now we can randomize the gates, for example, just by clicking this. We can randomize probability. Right, and we can randomize also the notes. Right, a useful key command is to hold shift while clicking them to bring them back to default. If you see random gates, shift plus click to init defaults, the same for probability and notes. So I hold shift and I click them, so this will bring them back to default. So for example, if I do something like this and I don't like it and I want to change things myself, I just hold shift and this will bring them back. Now for the pitch randomization, we have 3 options. We can again just randomize everything fully, right? Or if I bring this back, in the right click menu we have a few options, right? We can set the first as a minimum, so this will be the first step. So now, for example, if I use, let's say I bring it up here, let's say, right, something in the center, this will be the minimum value, and all of the other values will go above this when I randomized. Right, you can see whenever I randomize it, it stays above this value. But we can also set this as a maximum. Right, again, this will not change and everything else will be below this value when randomized. Right, so we can add some variation within this limitation that we can set, and we can also use something like a clock divider. As you can see, there are CV inputs here or trigger inputs for everything. So we can use a clock divider to change the notes for us. I have divided by 8 clock. Okay, so we can use the various trigger inputs to create more complex sequences. I have a sequence running forward only. It will play just the first 4 steps. This is a sequencing kick all from the FACO. Right, and for example, we can use probability to jump to a different step, also randomly. So I have here chances from count modula. In this case, it will add probability to the main clock. Right, so the main clock goes to the input, and then from output A we will get a trigger with probability, and I will use this to trigger the random input, which will jump to a random step in the sequence. Sometimes it will be in the same row, sometimes it will be in a different row. Right, so we have a bit more movement again. Sometimes it will be in the same row, sometimes it will trigger a note or a step, or it will jump to a step in a different row. So it will play a different set of 4 steps. Right, another idea would be to use something like a burst generator. Here I have the one from count modula. I will clock it with a clock multiplication of 3. So we get triplets. This will go to the external clock. Let's say we will have 5 pulses, a burst of 5 pulses. Right, this will go to the, let's say, the down arrow input, and I will use it divided by 8 clock to trigger it. And then every time it's triggered, it will create a burst of 5 steps that will run as triplets, sort of ratcheting, if you will. Just like this. Right, so we get this interesting moving sequence. I have here another voice, another sequence, in this case with 2 FM operators as an FM voice. Right, and listen to what happens before I explain what's going on. Right, so what I have here, I have a clock triggering the forward input, right? So we have 4 steps. And then I have an unsynced burst generator that will generate a burst of 16 triggers. And this is triggering the random input, so we just get random steps. But I'm using the end of cycle output, so whenever this burst ends, to reset the sequencer. So what's repetitive in this one, it will always start with these 4 steps, and then we will get a burst of random steps. Okay, we also have the YX outputs, one for the gate, one for the pitch. They will output the inverted step values, not the inverted voltage, but the inverted position of the current step, which can give us another sequence we can use. Here I have it sequencing one FM operator with some random voltages, adding some movement. Right, again I use the forward with a multiplied clock, the down with a divided clock. Right, and now I can use the YX outputs to bring in another voice, in this case another FM operator, that will be as a stereo voice, so one will be on the left, one will be on the right. And you can hear the variation. Right, now, by the way, we can use the grid sequencer also for percussive voices. So here I have one sequencer sequencing a kick and hi-hat with tremor 2. I have the range set all the way up, so instead of notes we will get more or less something for modulation or automation, and the scale is set also all the way up to none, so we don't have quantized voltage, and again we can use this for modulation or per step automation, if you will. Right, so I have it triggering a kick and a hi-hat, and the values of the notes or of the steps will modulate once the decay of the oscillator, once the decay of the noise. Again, I'm using two different clocks here. This you can use also for percussive voices. And I have here another sequencer sequencing two kick all modules as a stereo bass voice. So again, I'm using once the original outputs and once the inverted. Again, not the value itself is inverted, but the position is inverted. So if we have this step from the original output, we will get this step from the inverted one, right, and so on and so forth. And you can see I have two chances modules, adding probability to the steps to where the sequence will actually move. I want to quickly show you a few more options we have in the right-click menu. I will run this sequence, I will run the clock. Right, and for now it's set to trigger, so the signal we will get out of the gate output will be a short gate signal. You can see this quite clearly on the scope. Now there was a time that this signal was even shorter, it was really a trigger, and that's why there is also the re-trigger mode. But for now, this behavior changed, so now the retrigger will basically output the same gate signal. Right, we have also continuous, which will keep the gate open on consecutive steps, right? So if there are steps, like here for example, there are 4 steps one after the other that are active, you see the gate is also open for longer. Right, I will bring this back to trigger. And now we have also the option to ignore the gate for volt per octave output. Basically, this will turn off or on the internal sample and hold function. So if I activate this, you can hear we have pitch changes also on steps that are not active. Right, but if I turn this off, now the pitch will change only together with the active step as a sort of a sample and hold, internal sample and hold functionality. Right, and that's it for this lovely sequencer. You can see how much potential it has and how much fun it can be. Thank you again so much for your support. I hope you enjoyed this video. Cheers.